We are on chapter 4, lesson 3. So yesterday we had rational expressions. A rational expression means that I have a fraction that has maybe a binomial in it or a trinomial, exponents, lots of different variables. So yesterday when I was multiplying rational expressions, I had to factor everything that I could first. And then when I found things that were in common, I was able to simplify by canceling out. So today I'm dividing. And the only difference between division and a problem that we did on the board is that if I have 1/2 divided by 4/9, I just wanted you to remember from elementary school that the second fraction is flipped, reciprocal, the second fraction, and then I multiply straight across. So my answer would be 9 eighths. Okay? So today, I'm going to be giving you two fractions. Your job will need to be to reciprocal the second fraction. Okay? All right, so I'm starting with number 1. If I know that I need to reciprocal the second fraction, let's factor everything first. I am going to give you a freebie because when you look at this, our first instinct would be, let's try grouping. It's 4 terms. Let's try grouping. Well, upon further investigation, you cannot group. So I need to just tell you the answer. The answer is x plus 1, and it's cubed. I keep wanting to write a 3. It's x plus 1 cubed. It's basically a sum of cubes. And the reason it doesn't look familiar is because when I've given you sum of cubes, I've told you the format. I've never had you multiply it all out and FOIL it all out. So sum of cubes, you only know is a binomial and then a trinomial. But when you multiply it full on out, sum of cubes, x plus 1 cubed, turns out to be this. So 1 minus x squared. Well, it's backwards. What do I do when something's backwards? Yeah. I can multiply by -1, and then I'll get x squared minus 1, which is really, right, x plus 1, x minus 1. And then I'm going to factor my second fraction. I'm not flipping it yet. I want to factor everything right off the bat. X squared plus 5x plus 4. What is it? It is good. X squared plus 3x minus 4. What is that? I want a positive 3 when I add.
X plus 4x minus 1.
True. So now, I know that the second fraction needs to be flipped. I'm going to rewrite the first fraction in its simplest form, which is x plus 1, x plus 1, x plus 1. My denominator is -1 times the difference of squares, x plus 1, x minus 1. And I'm going to multiply to get, the reciprocal, the second fraction. Now I'm going to multiply. The denominator comes up. So x plus 4, x minus 1 is now the numerator. I reciprocal the second. X plus 4, x plus 1 is the new denominator. Okay. Cross out all the things you can. X plus 1. Another x plus 1. X plus 4. X minus 1. Final answer. So I'm going to write it two ways. They mean the same thing. I can apply the negative sign to both. Yes, ma'am.
What about the other x plus 1?
find another one to cross this out with. It has to be in pairs. So this is, there's nothing on the bottom left to cross out, so I'm going to leave it up there. I'm asked to find the domain. Remember, my denominator cannot be 0. Domain. Fancy brace. That's not even that good. What cannot, okay. What number can I not have in the denominator?
+1.
Guys, go back to the original. Way to the original. There's lots of choices. I cannot have, x cannot equal what?
-1.
Or
1.
1 or
-4.
close brace. I don't want my denominator to be 0, so I'm writing down the numbers that would make my denominator 0, because those are not good numbers. Okay. Example 2. Let's factor it out first before we flip again. So go ahead and, like on the denominator, take out an x. You should multiply this by -1. The denominator of this one can be 3x, x minus 6. So factoring, there's some GCF, right? I'm going to reciprocal the second fraction. And this is what I got. Flip the second fraction. And then cross out what you can. X minus 6, x minus 6. An x and an x. So the only thing on my numerator is a 1 times a 3. The only thing in my denominator is the negative sign and the x plus 9. Then I'm asked to state the domain. Go back to your original up here. Set that equal to 0, set that equal to 0, and set that equal to 0. There's 3 different things that I could set equal to 0, or you just write, the opposite number. So any number in the whole world is going to work in the denominator. However, I do not want my denominator to have a, so this x is all alone. It still needs to be set equal to 0. X cannot equal 0. What else can't it equal? -9. What else can't it equal? 6. Close brace. Go ahead and do example 2 on your own. All right. Sorry, it's all like dead air on my video, so I gotta. So you GCF the numerator. Can't do anything with x plus 5. Cross out what you can. Did you get 2x?
Yes.
Good. That was it. If you need to look it over, here it is. Domain. 2 numbers in the domain. Domain is all real numbers. However, my restrictions are x cannot equal what and what? And
Six.
6. So I look at my denominator before I simplify. Okay? Now, I need to explain to you the backside because what I'm going to do is I'm going to, okay, if you are watching this video, can you please pause the video on this page because this is the information that you'll need to copy, but I don't want to have no one talking for 5 minutes while you copy it down at home. So can you just pause the video right now, please? So what's happening is I have 2 box sizes, and this company is trying to decide should they use a cube box, just like perfect square, or should they use a cylinder. However, no one ships something in a cylinder unless it's a poster, so it's kind of weird. But anyways, can you imagine your Amazon packages coming in all cylinders? So, the way to figure out the maximum, amount that you can fit inside a box is going to be, they figured it out. Now, this is this company's decision to do the ratio of the surface area and the volume. So, a cylinder. Did you know that a cylinder is a circle on top, a circle on bottom, and then a rectangle? That's the surface area of a circle, the outside. Think of a soup can. If you take the label off, isn't that a rectangle label?
Yeah.
And then a circle on top and a circle on bottom.
Yeah.
So, the circumference is the length. The circumference of the shape of the circle is the length of the rectangle. If I unwrap the label, it's the circumference that tells me how long that paper label is. So this is the circumference, 2 pi r. The radius is x. Radius is x. So the height of the cylinder is 2x. Length times width. I have to find the area of the rectangle, and I have to find the area of the 2 circles. That's surface area. So the cylinder is going to be, the surface area is found by finding the area of the 2 circles, pi r squared, pi x squared, plus the area of the rectangle. Length times width. Width times length. The box, every side is length times width, 2x times 2x, 2x squared, and there's 6 sides. Surface area, 6 times 2x. And then I did the volume. I guarantee, since geometry, you've probably forgotten the volume of a cylinder. I should get out of the way. It's very obscure. You really don't need this in life too much. So, So once we get the data, we're looking at the ratio of the surface area divided by volume. Surface area divided by volume. I'm moving the page just a little up. These reduce to be the same ratio. 3 divided by the, and x, remember, was the radius of the circle. X was also half the length of one of the sides of the box. So I am going to stop recording the video because, I don't need to. Thanks for watching my video.